Questions 1 through 10 of the 2001 Grade 8 AMC 8. Casey's shop class is making a golf trophy. He has to paint 300 dimples on a golf ball. If it takes him 2 seconds to paint one dimple, how many minutes will he need to do his job? So 2 seconds to paint one dimple. He's got to paint 300 dimples. So 2 seconds per dimple times 300 dimples. And this looks like 600 seconds. Now they want the answer in minutes. So 600 divided by 60 is going to give you the number of minutes, and therefore that's 10 minutes. So the answer for number 1 is D. I'm thinking of two whole numbers. Their product is 24 and their sum is 11. So you have two whole numbers, and when you multiply them, A times B, it becomes 24. And when you add them, A plus B, it becomes 11. So this is really done by inspection. This is a grade 8 math contest. You're not going to, make this into a quadratic equation and all that stuff. So just based on inspection and trial and error, you'll be able to get that A is 3 and B is 8. And you can verify this, of course. 3 plus 8 is indeed equal to 11, and 3 times 8 is indeed equal to 24. And they want the larger number, so that would be 8. So the answer to number 2 is D. Granny Smith has $63. Alberta has 2 more than Anjou, and Anjou has 1/3 as much as Granny Smith. How many dollars does Alberta have? So we've got Alberta, Anjou, and Granny Smith. Well, for Granny Smith, they've told you already that her amount is 63. And Anjou has 1/3 as much as Granny Smith. So 1/3 of 63, which is 21. And then finally, Alberta has 2 more than Anjou. So if Anjou has 21, Alberta must have 21 plus 2, which is, of course, 23. So the answer to number 3 is E. The digits 1, 2, 3, 4, and 9 are used once to form the smallest possible even 5-digit number. The digit in the tens place is. So you're going to form a 5-digit number, and it's even. And you want the smallest possible using these 5 numbers. All right, so if you want the smallest possible number, the smallest numbers have to go first. So the 1 is going to be the very first number, the 2, and then the 3 will be the next. Now you got 4 and 9. It's an even number, so the last digit by process of elimination must be a 4. And therefore there's only 1 digit left, and that's 9, and that's going to go in the tens position right here. And that is the digit that they're asking about. So the answer to number 4 is E. On a dark and stormy night, Snoopy suddenly saw a flash of lightning. 10 seconds later, he heard the sound of thunder. The speed of sound is 1,088 feet per second, and 1 mile is 5,280 feet. Estimate to the nearest half mile how far Snoopy was from the flash of lightning. So here is Snoopy, and somewhere far away is this lightning. And he initially hears it, but it's a 10-second delay, right? So, and you guys have experienced this in your own life where you see something and then a little bit later you hear it. It's usually not 10 seconds. 10 seconds is a long time. It's usually like 1 or 2 seconds. And the reason you'll see it before you hear it is because the speed of sound is slower than the speed of light, right? But we don't need to get into all that. We just need to figure out how far away is the lightning. Well, there's a standard formula, right? That distance is basically the speed times the time. So they want us to figure out the distance. The speed is 1088 feet per second. And the time that it takes for him to hear the sound is 10 seconds. So 10 seconds. So this looks like 10880 feet. And they want the answer in miles. So 10,0880 divided by 5280. And this is a little bit over 2.1 maybe, or 2.0 something. So that's what they're asking, to the nearest half mile. So the answer to number 5 is C, 2. 6 trees are equally spaced along one side of a straight road. The distance from the first tree to the fourth tree is 60 feet. What is the distance in feet between the first and last trees? All right, so we've got this road here. And along this road, you've got some trees. You got tree here, tree here. You have 6 of them, right? So here, here, and like that, equally spaced. So that's the key there. Then they're saying the distance from the first tree to the fourth tree is 60 feet. So if this is the first tree and this is the fourth tree, this distance is 60. Now these trees are equally spaced, so that means this distance is 20, that's 20, and that's 20. All right? 60 divided by 3, basically. And then they're asking what is the distance in feet between the first and last. Okay, this is the last one right here. Now, if they're equally spaced, the distance between the fourth and the fifth is 20, and the distance between the last two is also 20. So the full distance between the first tree and the last tree is 20, 20, 20, 20, 20, which would be 20 times 5, which is 100. So the answer to number 6 is B. All right. To promote her school's annual kite Olympics, Genevieve makes a small kite and a large kite for a bulletin board display. The kites look like the one in the diagram. For her small kite, Genevieve draws the kite on a 1-inch grid. For the large kite, she triples both the height and width of the entire grid. What is the number of square inches in the area of the small kite? Well, to figure out the area of the small kite, we can figure out the area of the entire rectangle and then subtract from it these 4 triangles. So the area of the entire rectangle are basically the dimensions of the rectangle. So it's 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4, 5, 6, 7. So 42 is the area of that entire rectangle. And now we have to subtract the 4 triangles. So 2 of them look like they're exactly the same. So 2 times the area of a triangle, which is 1/2 base times height. The base we can say is from here to here, which is 3. And the height is from here to here, which is 2. And then we have to add to this the other 2 triangles. The base, so we have 2 times 1/2 base times height. The base is from here to here, which is 3. And then the height is from here to here, which is 1, 2, 3, 4, 5. So this looks like 6 plus 15, which is 21. So to get the area of the kite, we have to subtract from the full area, the area of those 4 triangles. So 42 minus 21, which is 21. So number 7 is 21, which is A. Number 8, Genevieve puts bracing on her large kite in the form of a cross connecting opposite corners of the kite. How many inches of bracing material does she need? So she's putting this bracing material right here, connecting opposite corners. like that. All right. So how many units is that? 1, 2, 3, 4, 5, 6 across, plus 1, 2, 3, 4, 5, 6, 7 down. So that's 13. But this is the large kite. And in the question it tells you for the large kite, she triples both the height and weight. Height and width, not weight. So instead of 13, we have to triple that. We have to triple those values. So 13 times 3 is 39. So 8 would be E. And now number 9, the large kite is covered with a gold foil. The foil is cut from a rectangular piece that just covers the entire grid. How many square inches of waste material are cut off from the 4 corners? So you're taking a gold piece of foil that essentially is the same size as the grid, right? And you are going to use it to cover all of this kite. But we actually don't need the whole material, right? We just need enough to cover the kite. So that means that you're going to eventually cut off the corners like that, or the triangles. And they're asking you, when you do that, how much did you waste? All right, that shouldn't be a problem. Probably just have to calculate the area of those 4 triangles. So let's do that. The 4 triangles, of course, very similar to number 7, will be 2 times 1/2 base times height. So the base of the top there is 3 for one of those triangles, and the height is 2. Like that, right? But remember, this is now the large kite. So we have to triple these values. So don't get confused there. Don't put 3 and 2. Think about the question, read the question carefully. We're tripling. So instead of 3 and 2, we have to put 9 and 6, right? Because we've got to triple the values according to what the question tells us. And then similarly, if we figure out these triangles down here, there's 2 of them on either side. So 2 times 1/2 base times height. The base is 3, but we have to triple that. So 9. And then the height is from here to here, which is 1, 2, 3, 4, 5. And we have to triple that. So we write 15. So therefore this becomes 9 times 6, which is 54, plus 9 times 15, which is 135, which totals 189. So 189 is the waste material, and that would make number 9 equal to D. A collector offers to buy state quarters for 2,000% of their face value. At what rate? At that rate, how much will Bryden get for his 4 state quarters? Those of you watching outside of North America, a quarter is a coin. And it's a coin whose value is 25 cents. So similar to other countries, you have centavos, or you have other units of currency. In the United States and Canada, the unit is dollars and cents. So you're getting 2,000% of the face value. So 2,000% is how much in terms of a factor? You have to divide by 100. And that gives you the factor. So in this case, it's a factor of 20, right? So for example, if something was 200%, it would be 200% divided by 100, which is a factor of 2. All right, so be familiar with that. That's important. So he's got 4 of these state quarters. And the value, of course, therefore, would be 4 times 25 cents, like that. And this is, of course, $1. Now he's going to sell it at this whopping 2,000%, which is a factor of 20. So you have to now multiply $1 by 20 to get the amount that he's going to sell it for, which is, of course, $20. And the symbol for dollars is like that. So 10 is A.